In the previous video, we started talking about entities and we covered the weak entity type and the strong entity type. We gave the employee and dependent example. Another example would be building and room. So if I have building, let's say I have building number one, then I can assign rooms for that building. But if I don't have that building in my system, I cannot have the rooms in that system as well, because where will the room belong? The room cannot exist without the building existing. And this is another example of a weak entity versus a strong entity. Now, for the naming guidelines for the entities, we have some guidelines for naming entities. And the entity name should be a singular noun. We use capital letters for those entity names. And we want to make it clear. So we want to know what the instances might be by just reading the entity name. It's possible to say the entity name is S, but then what would S mean? Is it students? Is it something else that starts with S? Is it something that doesn't have to start with an S? But if we say the entity name is student, by just reading the entity name, I can know what instances might be inside that entity. It also has to be specific to the organization. So if I say my organization is a school, student entity makes sense. But if I say my business would be something like a bank, then student wouldn't make sense in that case. We need to make it concise and abbreviated, so we want to use as few words as possible. Now, it does not have to be one word. It can be 2 words, 3 words, but we want to make it as few words as possible. And the last thing, it needs to be consistent throughout the diagram. So we will move from ERD to other diagrams, and we want to make sure that this name is consistent through the diagram. Now, we don't want to have two entities with the same name, because this is going to raise confusion, and later on when we want to translate our ERD into a database, this is going to give us some issues because we cannot have two tables with the same name. And eventually our entities are going to be the tables in our database. Now, inside the entities, we have attributes. So what is an attribute? So the attributes are characteristics or properties about an entity. Let's look at some examples. If we have student, then the possible attributes might be student ID, name, home address, phone number, and possibly major. If we have automobile, then it might be vehicle ID, color, weight, horsepower. We can add more based on the requirements that we have in hand. Third example would be employee. We have employee ID, name, payroll address, skills, and so on. More examples would be something like department, where we have department name, department phone, department chair, and we can have more attributes as per our requirements. Now, for the attributes, we have some classification of those attributes. So we have required attributes and we have optional attributes. We have simple attributes and we have composite attributes. We have single valued versus multi-valued attributes, stored versus derived, and then we have what we call identifier attributes. Now let's start by talking about required versus optional. So a required attribute, from the name, it says this is an attribute that must have a value for every entity or relationship instance with which it's associated. So it is something that we will have to have it in there. And for the optional attribute, it's an attribute that may have a value or may not have a value. So we don't have to have a value for that attribute. Now, An example that most of you might have encountered is when you fill out an online form, you see the red star saying that this is a required field. Why is that a required field? Because in the database, they programmed it in a way that this has to have a value. If it doesn't have a value, it will prevent insertion in the database. If it doesn't have the star, then that means this is an optional. So even if you don't have a value for it, the database will not complain. So this is an example where if we look right here, we have all of the attributes required, but then for the major, it's optional. So this assumes that students may not have a major when they just join. So we can insert a record with the optional attribute and we can insert one without the optional attribute. Now, if we ignore any one of those required attributes, the database will reject the record insertion. The second one we want to talk about is simple versus composite attributes. So the composite attribute will have meaningful component parts, which are more detailed attributes. An example of this would be an address. So for the address, you will have, for example, the street name. Street name is a meaningful part. You will have the city, which is a meaningful part. State and zip code, all of those are meaningful parts. But when we combine them together, we get something that's called an address. And this is what we call a composite attribute. On the other hand, we have the simple or atomic attribute, which cannot be broken down into smaller components that are meaningful. So if I say, for example, student ID, this cannot be broken down to parts. If I say vehicle color, this also cannot be broken down into parts. Now, how do we model them? For the composite attribute, we write the name of the attribute and then in parentheses we include all of the parts. So for example, we have employee address and then we have the parts of that address inside the parentheses. For the simple attributes, we just write the attribute without any parentheses, without anything to say that this is a symbol, because by default it's a simple attribute. Now, single valued versus multi-valued attributes. A multi-valued attribute may take one or more value for an entity or relationship instance, while single attribute will take only one value for the attribute instance. And for the multi-valued notation, it's the curly braces. So an example would be skill. So for the employee may have multiple skills. So we want to have all of those skills listed, and we will say, okay, this is a multi-valued attribute. Now, a multi-valued attribute is different than a composite attribute. The composite attribute will have meaningful parts that will contribute to an overall attribute. And those meaningful parts do not fall under the same category. So for example, when we look at the address, the street name is not the same as the city name. I mean, not the same category. This is a street name, this is a city name, and then we have a state name, and then we have zip code. So these are meaningful parts, but they don't fall under the same category. But if we look at the employee skills, for example, the skills can be using Microsoft products, speaking multiple languages, and so on. All of those fall under the skill category. Now, the next one is what we call stored versus derived attribute. So a derived attribute is an attribute whose value can be calculated from related attribute values. And the stored attribute is something that we cannot calculate, but we will have to enter to the database. A good example of this is going to be date of birth and then age. So we can calculate the age based on the date of birth. So we enter the date of birth, which is going to be a stored attribute, and then the derived attribute would be something like the age. Or for example, date of employment would be our stored attribute, but then the calculated attribute is going to be, let's say, years employed. Why don't we store the other one? Why don't I store the years employed and try to calculate the date? Because if I store the years employed, I'll have to update this every single time. But if I insert the dates are going to be set, but then it's just a matter of code that is going to calculate or just subtract the current date from the other date and will give me the years employed. And that's how we distinguish between derived and stored. Now the notation is going to be square brackets, and whenever we see square brackets, that means this is a stored attribute. And this is an example of stored attribute, years employed. We will get it from the date employed. Now, the identifier attribute is the last type of attribute that we want to cover. And it's going to be an attribute or possibly a combination of attributes whose value distinguishes individual instances of an entity type. So a composite identifier is an identifier that's going to consist of a composite attribute. So remember the composite attribute that we talked about? This can be an identifier attribute as well. Now, an example of an identifier that is not a composite identifier would be student ID, but then a composite identifier might be flight ID, because you know flight IDs consist of flight number and date. So if I have flight going from, let's say, city A to city B, then this flight number is usually not going to change, but they change the date. But then if I have flight number, let's say 001, and the date is January 1st, and then I have another flight number 001, and the date is January 2nd, then those two flights are different. And this is going to be the composite identifier that is going to identify the date for me. Now, there are some rules for the composite identifier. It must be unique across all instances. So I cannot have the same identifier for two instances. When you try to choose your identifier, look for something that will not be repeated over instances. So each instance will have its own unique identifier, and this is not going to be repeated, like student IDs, social security numbers, and so on. This again is not going to change over the life of the instance, and it will always have a valid value. You cannot have it set to null, which is nothing. You cannot have it as no value in there. It has to have a value, and it will be usually called the key, and some will call it the primary key. And the notation is going to be boldface and underlined, something like this. Now, can first name be an identifier? The answer is no, because basically we might have some people with the same first name. And can birth date be an identifier? The answer is in most cases no as well, because in every day we have many people that are born. So if we have more people born in the same date, then we will have the same identifier as well. So these both are not valid identifiers. Now the primary identifier, which is the primary key we talked about, is often referred to with the letters PK, which refer to primary key, must be a unique attribute among all data instances. Again, suitable primary keys will be student ID, the VIN number for the car, and in the case of flight, then it might be flight number combined with date. And suitable primary keys, as we said, first name, room number, flight number alone, because again, airline companies will have the same flight number, but will combine it with date to have a key. Now, these also could change or have duplicate records with other attributes. Now, is this a good key? Flight number, date, pilot name, plane model, number of passengers. So if I combine all of those, I will not get the same key. But the problem with this is it's very long. So I only need the first two parts, which is going to give me a unique identifier, and I don't need the rest of the parts. And that is why this is not a suitable primary key. Now, we also have guidelines for naming attributes. As we have guidelines for naming entities, we also have guidelines for naming attributes. So the attribute name should be a singular noun again, or a noun phrase. It will only start with a capital letter. Remember previously in the entity, we said the entity name will all have uppercase letters for the whole name. For the attributes, it's going to be starting with an uppercase letter. The name should be unique, so no two attributes of the same entity type can have the same name. So I cannot go for the student and say name and then another attribute saying name and one of them is first name and last name. This will not work. We need to follow a standard format to all attributes. So this is only for clarity purposes. So if I follow the first one for hourly rate, I need to follow it with every single attribute, or I can use hourly rate as full words and it's going to be fine, but I need to follow it with all attributes as well. And finally, we need it to be relevant to what it means. So I cannot say H for hourly rate because it's not going to be kind of relevant to what it means. So I want it to be named in a way that when I just read the name, I can know what attribute is going to be stored in there.